back, ladies and gentlemen. We are going through our fifth video today, and the focus is on a concept known as dimensional analysis. Now, this is a very important concept, and it may seem fairly easy at first, but it will get more complicated as we continue through this chemistry course. So I will say that there are several sets of rules that you do need to follow, and just to be perfectly honest, this is probably one of the most important concepts that I will teach you in this chemistry course. So please make sure you pay attention, make sure this makes sense, and hopefully you won't have any problems with this moving forward. So we just have one learning target today, and that's to be able to use conversion factors to convert the units of one material to another unit. And that's the whole goal of dimensional analysis. We're just taking equivalent substances of one unit and converting them to another unit. And you'll see what I mean here in just a minute. Just a couple of key vocabulary terms here: conversion factor and dimensional analysis. Let's get started. So if somebody gives you $1 and asks you to make change, you probably know how to do that. So for example, you would provide the person 4 quarters for $1. 4 quarters is equal to $1 in value, yet they are two separate units. And so when we talk about conversion factors in chemistry, it's that same concept, that we're converting from one unit to another using different units but equal amounts of each. So for example, 4 quarters is equivalent to $1, the same as 2.54 centimeters is equal to 1 inch. And we express them as fractions to help convert between a variety of different units, and this concept is known as dimensional analysis. So if I were to give you $2, you would then know that 8 quarters is equivalent to that, because for every 4 quarters is worth $1. It's the same concept here. And if we take a look to the right, we have a variety of useful conversion factors and relationships, and you have one of these in your course packet that you'll be able to use on a variety of different tests, or I'll provide one for you. But as you see here, 1 kilometer is equal to 0.62 miles. A mile is 5,280 feet. You probably know that a foot is 12 inches, a kilogram, 2.2 pounds, and so forth. And we'll be using a lot of these different factors in class this year. So keep in mind that the conversion factor, if you look at those two down at the bottom where it says 4 quarters and $1 and 100 centimeters and a meter, they're both equivalent amounts, meaning that 4 quarters is the same as $1, but they're in two separate and independent units. So when we're using conversion factors to be able to solve dimensional analysis problems, there's a few key things that we have to be able to do. First part is we need to determine the given and the unknown in the problem. So we need to make sure we read it carefully, figure out what is given to us, what is unknown, and figure out how to solve for that. Step 2 is to find a conversion factor that connects the two units in the given and the unknown. And keep in mind, you may need more than one conversion factor to solve correctly. Sometimes it will require 2, 3, even 4 steps in order to get where you want to go. Step 3 is probably one of the most important ones you need to understand. When writing out your conversion factors to solve, the unit from the previous step, the unit on the top of the previous step, must go on the bottom of the next step. I will repeat that until I am blue in the face and dead in the ground. The unit from the top of the previous step must go on the bottom of the next step. That is so that the units will cancel. You'll see what I mean here in just a minute. And then we use math to solve for our unknown. So let's take a look at this first problem here. Express the mass of 4.378 grams in milligrams. Step 1, determine the given and the unknown in the problem. Well, the given is 4.378 grams, and our unknown is our mass in milligrams. Step 2, we need to find the conversion factor that connects the two units in the given and unknown. Yes, I see a typo there. Big deal. You want to fight? No, I'm just kidding. I'm a pacifist kind of guy. Anyways, the conversion factor here, if we remember from our last video, refers to the fact that milli of something means 1,000. So there's 1,000 milligrams inside 1 gram of a substance. Now these equal the same amount, but again, they're in two different units. So when we write this out, we write out our first unit. We write out what is given in the first part of the problem. So you see 4.378 grams. And then we multiply that by an equivalent set of units, our conversion factor. Remember that the unit from the previous step must go on the bottom of the next step. So grams on top of the first step goes on the bottom of the next step. And 1 gram is equivalent to 1,000 milligrams, like what we talked about before. Our grams would cancel, because grams divided by grams would be 1, and then we would just do math in order to solve the problem. So we would take 4.378 and multiply by 1,000, which gives us 4,378 grams. You'll see this a little bit more on as we continue through more practice problems, but again, the concept is still the same. Figure out what you're trying to get and what you already have. Find a conversion factor that converts between the two. Write out your known first, and then use the conversion factor to move to the next step. But keep in mind, the unit from the first step, on top of the first step, has to go on the bottom of the next step. Do your math and solve. So let's do a problem together. So let's take a look at our first problem. Convert 3.54 feet to inches. Well, again, our first step, determine our given and determine our unknown. Our given is 3.54 feet. And our unknown is in inches. So we need to think of a conversion factor between feet and inches. Now this one's pretty straightforward. Hopefully you all know that 1 foot is equal to 12 inches. Pretty common conversion factor that we use on a day-to-day basis. So again, when we write out our problem, we always start with our given, 3.45 feet. We multiply. Remember what I said before, whatever units on top of the first step goes on the bottom of the next step. And then we can directly convert feet into inches. We've got our units here, so 12 inches into 1 foot. Our units of feet cancel. That leaves us with inches left over, which is what we want. And then we're going to do some math in order to be able to solve this. So we're going to take 3.54 and multiply that by 12. When we multiply, we get our answer, 42.3 inches. So again, same concepts apply here. Just take what is given, find a conversion factor, make sure your units are set up appropriately, and solve, and we get our answer. Let's do one more problem together. All right, ladies and gentlemen, let's take a look at our final practice problem here. And it looks like it states that we need to convert 34.77 meters to inches. So again, we need to look at our given and our unknown. Our given is 34.77 meters, and our unknown is in inches. So we take our given, we're going to start off with that, so 34.77 meters. Now, again, the unit on top of the first step has to go on the bottom of the next step. Now, we need to convert meters into inches, and if we look at our chart, there is not a direct conversion between meters and inches. So what we need to do is find an intermediate step. That is, we need to convert meters into something else so that we can then convert that something else into inches. So this is going to require multiple steps. Well, if we take a look at our chart, we do know that we can convert meters into centimeters. And if you remember, there is 1 meter for every 100 centimeters. So then, again, we look at our units here, not the same as inches, so we need to go one more step. So again, the unit on top of the first, or the unit that's on top of the previous step goes in the bottom of the next step. And we look at our chart, there is a direct conversion between centimeters and inches. And if we recall, there's 2.54 centimeters for every 1 inch. So we took our units, meters will cancel, centimeters will cancel out, leaving only inches as our unit, which is what we want. And now we just do our math. So we'll take 34.77 multiplied by 100, and then we'll divide that number by 2.54 to get our answer. And if we do our math correctly, our answer will be 1,369 inches. So again, the rules are still the same. Write out what we know. Whatever unit's on top of the first step goes in the bottom of the next step. Try to find a direct conversion factor. If one is not available, convert it to something, and then take that unit, put it on the bottom of the next step, and use that to convert into what you're looking for. So follow these steps. Like I said, it's like a map. start with what we know, and work to get to what we don't know. Just a few key tips. Keep in mind that dimensional analysis is like a road trip. You know where you start, and you know where the destination is. But your job is to figure out how to get there using a variety of conversion factors, either some of the metric ones that we've talked about or some of the ones that we've looked at on our sheet. Keep all of those conversion sheets handy as you may need them, and also be sure to memorize the metric conversions of milli, centi, and kilo. All of these will help make your dimensional analysis experience a successful one. So hopefully you have a better understanding now of how to use conversion factors through dimensional analysis to convert from one unit to another. And keep in mind, this is one of the key topics that you need to know in order to be successful in chemistry class, as this is going to appear in many different units that we'll focus on this year. So again, hopefully you've reached the learning targets for this particular lesson. Wish you guys the best of luck, and we will practice some of this in class when you come back tomorrow. Have a great day, guys. We'll talk to you later. Bye-bye.